Привет, ребят.
Alright, so in this lecture we're going to take a look at conditionals in Kotlin. So we're going to talk about the if expression as well as the when expression. And we're going to see also that there really are expressions in Kotlin and not statements. So let's first of all go ahead and look at the if expression, which works pretty much the same way as in Java, except that it's an expression and not a statement. So let's go ahead and create an integer variable here and set this to 17, and then you can go ahead and check for exam. Well, if I is less than 15, you want to say print line I is pretty small. And let's actually go ahead and make this greater than, so that we actually get the message as well. And you can see that when we run this, it's going to come back and print out I is pretty small. I'm going to just use the arrow up key in order to go back to the last command. And what you can also do, of course, just like in Java, is to have an else block and say, well, in this case, else would be if I is greater or equal to 15, you're going to say let's say it's pretty large.
Привет, Тазбикс. Привет, Карина, привет, Антош, привет, Стась.
And of course, in this case, now that I've actually changed the condition to less than 15 in the if block, it's going to print out it's pretty large. And of course, just like in any other language, you can also have an arbitrary amount of else if blocks. Let's say else if I is greater or equal 15 and I is less than or equal to 25.
Да. И в стримгузельке взламываю, и читы кодю. Делаю все сразу. Ай, больше или равно 15. Где у нас амперсант? Ай, меньше или равно 25.
I'm gonna say it's okay, and you can have an else block at the end, just like in Java again, and say print line
Else.
it's pretty large. So you can also see that the AND operator here to combine two conditional expressions looks the same way as in Java, and you also have the OR operator here, also with the same syntax. And you can also use the exclamation mark to negate an expression. So let's go ahead and press Ctrl Enter to run this, and it's gonna say it's okay, because 17 is somewhere between 15 and 25.
Да,
Alright, so far everything exactly as in Java, but as I already mentioned, the if blocks and also the when blocks that we're gonna look at are actually expressions. So what you can do is you can go ahead and say val x equals and set this to the if block because, well, it's an expression, so you can assign it to a variable. Now in this case, if we run
well, x
this
После
doesn't
CS будет,
actually
не
have a
знаю.
return value, so
Посмотрим.
it's like assigning a void value to x. So if I go ahead and just put in x, control enter to get the value of it, it's not going to come back with anything because there's no actual return value for this if block. Now in order to define a return value, you can add a value to the end of, or to the last line of each block in here. So the last line in each block, so inside the if block here, inside the else if block, and inside the else block, will then define the return value. So let's say in this case we want x to be set to small, here we want x to be set to medium, and here we want x to be set to large. Now in this case, if I go ahead and run this,
is pretty small. Small. Тут должно быть x if, значит тут else if I больше равно чем 15% I. Print ln it's okay medium else print ln it's large.
and then try to print out x.
Сладкий
It's gonna
снов.
come back with medium in this case. Well, there's not actually anything coming back. I think I went a
Ребят,
bit too
ближайший час
fast
тут
there
ничего
for the
интересного не
Kotlin
будет,
REPL.
реально.
So let's actually go ahead and run this block here again and wait for the print line statement to finish. Alright, so it looks like the Kotlin REPL crashed on me there. Unfortunately, it seems like the preview version of Android Studio isn't too stable. But I recreated the variable I with the value of 17, and now let's go ahead and run this same block of code again to set the variable x using an if expression. Now you can see first it's going to print out it's okay, which comes from the actual print line statement in here. And now if I try to get the value of x, you can see that it has been set to medium. So this was the return type in this case of this whole block, which means that x was set to this value. You can put anything you want into this last line to define the return value. So it doesn't have to be a string, you can put any return value you like in each of the last lines in each block. Now one question you might have is, what kind of return value does the if expression have if there's no return value in the last line? So for example, before when we had print line, what's actually the return value of that? And the answer is that it's a Kotlin unit type, so you could basically define a value of this and say value is unit, but this is no use because, well, unit is basically what in other languages is referred to by void. So it's like no return type at all. In other languages is referred to by void. So it's like no return type at all, but it's just interesting to know that if you have a function also later on that doesn't define a return type, then the return type is implicitly unit, which is basically void. So you can of course feel free to ignore this possibility to have a return type for if statements and use them just like in Java. But remember that you do have this possibility, and it's actually quite useful in order to avoid that x here has to be initialized with null before the if statement, just in order to then set it inside, which is how you can often, or how you often have to do it in Java. So this is also again another way to avoid nulls in Kotlin by just returning them directly from if expression here. Because this way you don't have to initialize the value x here, but instead you can just directly set it to the return value of the if statement or if expression. Now one last thing I want to mention here for ifs
Типа того.
is that the Kotlin compiler is quite clever
Какой
in this
нашел урок.
regard when using nullable values. So let's say we have again a string, which can be a nullable string, and we're going to set this to, let's say, Kotlin in this case. So when you have this, remember you can't just call
Больше или равно? Ну типа того, да. Давай попробуем. Donate 100 if donate меньше, больше или равно 100. Мы сейчас даже по-другому сделаем. Блять, как там? Блять, ну это сложно. If donate больше или равно. Тихо. Println. Давай сюда музычку. Else println CB старина со своей мелочугой. Unresolved reference Кекова. Ты что-то забыл, видимо. Видимо, неправильно этот. Хорошо, еще раз. Блять. Well, donate. Вот так вот сделаем. Я неправильно этот. 100. Если I меньше, CB старина. Если... почему I, когда donate, потом else if donate больше или равен 100, 150, да. Давай музычку. Else ети ты шейх. Юнит мы зададим бич нормис шейх. Вот. Блять, да что такое? Да. Блять, ну ёб твою душу. Donate. Далеко ушел. Блять, int. Ёпты. Так лучше. Блять, геттер-сеттер еще давать. Не в пизду, короче.
String the length, for example.
Все.
String
Не, подождите. Подождите. Так. Where donate integer равен if. Стоп. Сейчас. Where donate 100. Потом. Давайте так попробуем. If. Сейчас. Блять, не то сделал. Ёб твою душу. Давайте, хорошо. Так, if donate меньше 100 рублей. Println бичуган. Else println заказывай музычку. Блять, но он не выводит, короче. Он не выводит на этом. На русском. Броук-бой будет. И шейк. Все, шейк. Хватить пока не надо. Блять, забавно. Все. Шейк. Блять, а как там? Блять, дай бог памяти. Ёб твою душу. Сейчас я вспомню. Kotlin input. Kotlin input пусть будет. Reading console input. Вот. String. Во. Давайте вот с этим вот покопаемся, короче. Так. Нам буквально нужна переменная a только. Потом тут начинаем раздрачиваться на if. If a больше или равно 100. Println you're a great guy, else println you're a fucking бомж. Так. Ага. Так. 50. Блять, это надо в этой программу писать. Ёб твою душу. Tools, Kotlin. Блять, файл. New project. Давайте попробуем. Empty activity. My application. Finish. Так, оставляем эту хуйню. Так. Alright. Control. Project terminal. Блять, это чё? Это configuration. Add new. Kotlin. Apply, похуй. Так, да блять, какой эмулятор? Нахуй мне эмулятор? Блять, ну давайте попробуем сделать не котлиновский, а джавовский. New project. А, блять, я ж в этой в студию, ёб твою душу. Егорыч, спасибо большое за подписку, спасибо, дорогой. Спасибо, родной, спасибо. Спасибо, родной. Спасибо большое. Спасибо, родной. Блядь, я тут не запущу, да? Привет, Эпсилон. Привет, дорогой. Так, а у меня же была Java и Development Kit. Блядь, ну давайте... Ёб твою душу. Текстовый документ, блядь. Бомж. Экзам. А, да, конечно. Сохранить. У меня что-то, блядь, нет этой хуйни. Ай, блядь. Главное. Свойства. Блядь, а где эта хуйня? Дополнительно. Действующий. Ёб твою душу. Я, наверное, даже сейчас не сделаю нихуя, да? Да когда удобно, Егорыч, тогда я подъезжаю, в принципе. Setup. Intel ID. Блять, а мне еще ID накатывать надо будет, ёб твою душу. Ладно, у меня, короче, не совсем понимаю, как это работает на Android Studio. А, 50, бля, спасибо, нахуй. 50. Да ёб твою душу. Это Kotlin, короче. Я думал, у меня получится, как в Java, короче, просто, типа, хуйню вывести и все. А тут же он только, блядь, под эти, под ДПК, блядь. Под ДПК я хуй что сделаю. Ну, можно на груве попробовать, но... ID и скриптинг консоль. А, у меня тут хуйня, да. Tools. Ну, блять, будем в репле сидеть уж, ладно, похуй. Привет, Настя. Так вроде же здоровались.
No, but if you go...
А, что там у нас? Value unit. Value равен. Вот просто пусть будет. Короче, кому надо, можете вот эту вот хуйню попробовать в этом. В IntelliJ ID, короче, ебануть, и оно сработает. Так, well, str двоеточие, string, точка, без точки, равен, Kotlin, if
string is not null,
str не равен нулевому,
and then go into the if block here, you can actually do things like print line string.length, and this in this case is gonna
println str length. Точку забыл. Спасибо за подсказку. 6. Да, примерно так и получилось.
Come back with 6 and without any compiler errors, because inside the if block here, what Kotlin or the Kotlin compiler is going to do is it's going to automatically cast the string here to a non-nullable
Привет,
string
привет,
type.
привет,
So
дорогой.
you can use this here without the save or the unsafe call operator, because Kotlin already knows that string can never be null inside here. So this is one of the ways that Kotlin handles nullable types really intelligently and really helps you to avoid any unnecessary
Ну да,
complexity
потихонечку.
in your code. So generally in many cases where you have an object that is nullable by its declaration but cannot be null at a certain point in the code, the Kotlin compiler will already notice this and then allow you to work with the object as a non-nullable type. And when we talk about object orientation later on, we're also going to see how the Kotlin compiler handles many more things intelligently like this
Kotlin.
for also types of
Это для андроида.
But for now this is all about the if expression in Kotlin. So let's now go ahead and move on to the when expression.
Поехали дальше. When.
Now that you know how to use if expressions in Kotlin, the only logical thing to look at next are when expressions. And of course they're the equivalent of the switch statement in Java and other languages, but they're more powerful. So let's take a closer look at how to use them in Kotlin. So let's first go ahead and create a new variable here again, in this case of course immutable, because we don't need it to be mutable. And I'm just gonna say the price is, let's say, 29. So I'm just going for an integer here first of all, just for simplicity, and just to show you how the when construct actually works. So now we can go ahead and say when price in parentheses and then open up a block using curly braces. So far pretty much the same as using switch here in Java. But now the syntax is very different. There's no case keyword or something like that. You just put the expression that you want to check for against the price variable on the left hand side. So let's say for example when price is 0, then you want to print line for free today. So you just use this arrow notation here to define the right hand side, or in other words what's supposed to happen if the price variable is 0. And similarly you could go and check for specific values like let's say 19, and that would be on sale for example. But a more interesting and also more useful way to use this in this case is to check for ranges. So let's say if the price is somewhere in 1 to 19, we want to say it's on sale. And that's exactly how you write this in Kotlin. So you can just use in and then simply create a range from 1 to 19 using the ... notation here. So this means now that this branch will be executed for any value between 1 and 19, both included. And similarly you could go ahead and say when it's in somewhere between 20 to 29, you're gonna say, well, normal price. And then next what you can also do is you can define a default case, just like in Java, but you use the else keyword for this. So you can say else, print line, overpriced in this case. And we can also go ahead and run this for now.
Price else println overpriced.
But you just check out what's going to happen. In this case, when the price is set to 29,
normal.
It's going to come back and say normal price.
But
there are also some other things you can do that I want to show you. So one thing is you can also have a function call on the left hand side. So one very simple function call would be just an addition, which is basically a function call on the plus operator. So you could say if it's 10 plus 20, you can say, well, slightly overpriced maybe, because it's going to be 30. But you could also call any custom function here on the left hand side, as long as the return value matches the data type of the variable you're working
На
with.
Java
And
похоже.
then also you can check whether a
Потому что
variable is not
это
in a
измененная
range
Java.
by simply using an exclamation mark like you would do in logical array. And then also you can check whether a variable is not in a range by simply using an exclamation mark like you would do in logical expressions. So when price is not in 1 to 19, well, let's go ahead and just write not on sale. And if I go ahead and run this now, then that's going to be the first block in this when expression or when statement that's going to be executed or that's going to match. Because price is set to 29, so it's not in 1 to 19, and it's going to print not on sale. And notice very importantly here that it's only going to print this, even though it would also match the left hand side here. So what's important to notice is that in contrast to Java, we don't need to use a break statement explicitly, because each of those right hand sides or branches here breaks automatically at the end. So you're only ever going to run into one of these blocks and not multiple of them, even if multiple left hand sides here would match the variable that you're checking against. And that's because in other programming languages like Java, forgetting to use a break at the end of every branch is actually a common source of defects in your code. So this is a design decision here for safety in your code. I think it's a good choice because there are really not many cases where you really want to have this behavior to really skip into the next branch.
Но это сильно проще Java, хотя бы потому, что не надо в конце ставить вот эти вот фигурные скобки после каждой хуйни, потому что в Java мы бы сейчас хуярили после каждой строки фигурную скобку, скорее всего. Вообще довольно удобная херня вот это вот when, когда, и потом ты просто перечисляешь условия. Потому что единственное вот на Java, что я могу вспомнить вот для такого, ну на моем низком довольно уровне, это через if-else реально все хуярить. If, там, price равен там нулю, println, for free today, else if, там, там price больше или равен одному, амперсент, меньше или равен 19, println на отдельной строке, non for sale, фигурная скобка, вот это вот все, и типа каждую ты прописываешь вот так вот. И в конце, да, идет else overpriced. А тут вот так вот простенько, просто по строчкам вот так вот херачишь, все. Это сильно проще, конечно. Сильно проще. Ну и короче, естественно.
To another syntax where you can just use the when expression or when statement without actually having any variable in there. And in this case, all the left hand sides before the arrow must be a Boolean expression. So what we could do now is we could say if price is less than or equal to 19, we could again go ahead and say sale. Then next, if the price is less than or equal to 29, and notice that it's only ever going to come into here if the price is greater or equal to 20, then we're going to say, well, normal price, and then we can use else. We're going to say print line over price. In this case now we have Boolean expressions on every left hand side, and of course we can still use else for the default case, and then it's going to come back and print normal price. Now later when we talk about object orientation, we can also check for types on the left hand side using something like instance of in Java.
Не, просто это булевая херня, типа булевая алгебра. Но он же не выведет 19.
Потому что у нас нет
price.
Which is just that it's an expression again. So same as with the if expression, we can have a return value for the when statement, or when expression I should say. So we could go ahead and say val, or let me actually go back with arrow up to our expression before. And I'm going to go ahead and say val x is equal to this when expression, and instead of printing out the strings, I'm actually going to make them the return type. So now this way they're going to define what the value of x should be, because now each of the branches here returns a string, meaning that the whole when expression here is also going to be of type string, and that's going to be assigned to x. So let's go ahead and try to run this, and then let's go ahead and print out x. And you can see, well, in this case it should come back with normal price, but I suppose that the IDE crashed on me again because it also showed IDE error occurred. So let me quickly go ahead and just copy this part of the code, then restart a new Kotlin REPL. Alright, so unfortunately the Kotlin REPL again crashed on me here in the Android Studio preview, but I just set it up again. So what I did was copy the code here that assigns x to the when expression, and I actually set the price to 39 in this case, just to get a different result for a change. So let's go ahead and run this block here again to assign x to the value of the when expression, and then let's go ahead and just say x to get the value of it, and it's going to come back with overpriced. So again, this is often helpful to avoid having to set x to null first in order to then...
Это получается, он заранее задал значение прайсу 39. Все, я вот это совершенно пропустил. Я думаю, как оно будет работать через булевую эту алгебру, которая типа либо правда, либо ложь, типа либо ложь, либо истина. Думал, как она работать будет. Он в самом начале задал типа цену 39. И потом, собственно, создал условия типа. Как раз таки. И через true-false он выдал тип. Типа это overpriced говно.
Initialize it in a
Все, я понял.
else block or in a when block like
Будь
this.
здоровый, родить, согласен,
Just to find out what kind
100%.
of value you want to set
Так и
it
есть,
to.
брат.
And this when expression here without actually having a variable in parentheses is just a good way to avoid having long chains of if and else if chains.
Ну вот
And
да,
instead using
это
the when
помогает сжать
expression
if
can
else.
make it more concise. But it's just a matter of taste, so you're gonna have to see whether you prefer to have this when expression or just if, else if, else if, else if, and so on. Alright, so that's it about the when expression in Kotlin. So again, notice it's an expression, not just a statement as in Java. You can check for specific values or ranges, or also check if it's not in a range. You can have function calls on the left hand side, and you use the else keyword for the default cases. And in contrast to Java, you can also have a when expression here without actually having a variable in parentheses, and then all of the left hand sides must be Boolean expressions. Alright, thanks for watching, and I'll see you again in the next lecture. When learning a new programming language, one of the crucial points is always to learn about their standard library and how to use it. Now, one of the most important parts of that is always the collections API, like in Java. And the great thing is, of course, when you come from Java and you want to learn Kotlin, there's not much of a transition cost because, well, also the collections API is based on the Java collections API, and generally you can use all the libraries and classes from Java in Kotlin. So coming from a Java background, it's really easy to get started, and in this lecture we're going to take a look at exactly the collections API so that we have a good understanding of also the differences in Kotlin and what Kotlin actually extends when compared to the Java collections. Let's go ahead and dive in. So as I mentioned, the Kotlin collections API builds upon the Java collections, and it adds many useful library functions. And another very important benefit is that in Kotlin there is a clear distinction between mutable collections and immutable collections, which of course is again aligned with the principle of preferring immutability in Kotlin. So for instance, in Kotlin there's a type list, which is generic, so you can have a list of int, for example, and this type here is only there to represent immutable lists. And the same also goes for set or map and so on. And if you do actually want to have a mutable list, there's another interface, mutable list, which adds all the methods which can actually, well, mutate a list, like adding an element, removing an element, and so on. And in contrast, the list interface only provides methods like get an element at index I and things like those, which cannot change the list. So the interface list of t only has the read-only attributes, and the interface mutable list of t has all the methods that can actually mutate a list. But now let's take a look at how to actually use them and create arrays, lists, sets, maps, and so on in Kotlin. And the great thing is that in Kotlin there are many helper functions to let you create any type of collection very easily. So let's, for example, go ahead and create an array and just set that equal to array of. which is the helper function to create an array. And you can see it takes a var arg of elements that you want to have inside the array. So let's just go ahead and say 2, 3, 5, 7, 11 and 13. And if you run this, you're gonna have the array variable here containing exactly that array of integers. So internally it's gonna be an array of int. And you can see that arrays, just like in Java, don't have a useful toString method defined. So they're just gonna give you the address of the array in the memory. Now if you do want to print an array, you can still use join toString. And let's try to use that without any parameters or arguments. We just use the default ones, and you can see that's going to have a nice result in the command.
Array.join toString. Whoa.
Alright, so next, when you want to have an array like this, you can actually also use specific helper functions, like in this case int array of, which will then internally use a primitive int type, just like in Java. So on the JVM they're gonna map this to Java's primitive int type, so you can also use int array of to use that. And there are also helper functions like double array of and so on. So very easy to create arrays, and the same also goes for lists. So there's list of, and you can simply create a list here. Let's say the Fibonacci sequence or the beginning of the Fibonacci sequence. Just create a list like this. And as you may already assume, this is actually going to create an immutable list. So this is again, of course, in line with preferring immutability in Kotlin. If you do want to have a mutable list, so let's say mutable list, you can use the helper function mutable list of, and that's going to create a mutable list that you can still modify. So you could go ahead and say mutable list at index 0 should be 99. And then if I go ahead and print this,
ну вот. Result reference. Блять. Mutable list 0 равен 99. Да чё unresolved reference? А, блять. Все. Mutable list 0.99. И, собственно, mutable list 99
You can see
367.
that the first element in the list is now 99 instead of 1. And of course, just to demonstrate, you can't do that with a list. So if I want to set this to 99, you can see we have an error which basically states that you cannot set any new element on this immutable list. And you can use this the exact same way as lists. So again, there's the helper function set of, and if I put in multiples there, then as you know, with a set you cannot have multiple instances of the same element in the set. So if I do this with 2 ones in the set of arguments, then the set here is actually going to come back with only 1, 2, 3. So the duplicates have all been removed. And of course you can again say mutable and use the mutable set of helper function in order to create such a
Ну
set
понятно, mutable это
where you can still add
изменяемое,
elements later on.
а все,
So
что не
this is then
подписано как
also going to
mutable,
use
это
the
неизменяемое.
interface mutable set, which also lets you add new elements, for example, or remove elements from the set. But let's first go ahead and just print this out, and it's going to come back with 1, 2, 3. But in contrast to the set above, you could now use functions like add or remove in order to change the set later on. Alright, so lastly, let's take a look at maps in Kotlin. So you can go ahead and say map is equal to map of, and then the map of function actually takes a var arg of pairs. So you could go ahead here and say pair of 1 to Kotlin, pair of 2 to Android, or whatever type you want. You don't have to have an integer as the key, you don't have to have strings as the values, you can use any types you want. In this case, of course, this variable here would be of type map of int to string, but Kotlin can infer that for us, so we don't need to do that here. So let's just go ahead for now and run this line to create this map with 2 entries in it, and then just try to print out the map. And this should normally come back with an output where it says 1 equals Kotlin and 2 equals Android. But the preview version here, or the REPL in the preview version, has some issues with printing out the results of the statements. So let's just go on and move on for now to see how to also create mutable maps, and also a nice syntax in Kotlin to create maps like this. So first of all, to create a mutable map, you can maybe already guess this, you can use the helper function mutable map of, and then just use the exact same kind of arguments. But to create a pair like that, you can actually use the to function in Kotlin, which is a very nice feature for this. So to make clear what's happening here, let's actually call it like this. To is just a helper function, just like mutable map of, that's available in your namespace or in your scope or automatically. So to is just a helper function that's available just like mutable map of or array of, and you could say here that you want to map 1 to Kotlin and 2 to Android. But what's great about this function here is that it's actually declared as an infix function, which we're going to take a look at later on in the course. So what you can actually do is you can use to as an infix function, so you can put it between the 2 arguments, saying mutable map of 1 to Kotlin and 2 to Android, and that's going to work just fine. And it's the same thing as calling the to function on the arguments 2 and Android. But it's just a very nice and readable and expressive syntax using the infix function notation. And of course, you're also going to learn later on how you can create your own infix functions, but for now it's just a nice tool to create maps in a more readable way. One last thing I want to mention about collections in general is you can easily create copies using the toList function. So let's say we want to create a list that has the same elements as our set variable, and we can just say list is set.toList, But be aware that this only creates a shallow copy, so if you have objects in there, those objects will not be copied recursively. But for collections of integers, doubles and so on, this is no problem and you can easily create a copy using toList. Alright, so that's all about arrays, lists, sets and maps in Kotlin. And what's important to take away here is that we have the clear distinction between mutable and immutable collections, and you should always prefer immutable collections unless you really do need to change collection later on. And also remember that there are those very useful helper functions you can use to create any kind of collection in Kotlin. That's all for this lecture, so I look forward to seeing you again in the next one.
Пять человек сидит. Что прям много. Думаю, меньше будет. Ну и давайте еще одно видео.
So now that we know about conditionals and also collections, it's now time to talk about loops in Kotlin. Now, especially when working with collections, oftentimes you want to iterate over that collection in order to do something with each of the items, for instance. So in this lecture we're going to start off by going into the for loop and see how we can use that in Kotlin. Now the first most simple example might be a loop that's just going to be executed 10 times. So we could go ahead and say for I in 1 to 10, and then we could go ahead and, for instance, print out I. And maybe add a space to this, so we're going to print out I plus a space so that we can actually differentiate each of the outputs. And now when I press Ctrl Enter, it's gonna come back with the numbers 1, 2,
Ну-ка. For I скобки. For I in 1 10 print I. No, it's
3, 4, 5 and so on. It's gonna print out all the numbers from 1 to 10. So there are several things to notice here. First of all, this is more like a for in loop in Java, where you have something like for, let's say, int I in, for instance, some list of ints. This is also a syntax that can be used in Java, but most of the time in Java you might also use a syntax where you have actually 3 parts to the for loop, where you define a variable, then define some kind of condition, and then increase the variable here, for instance. And this kind of syntax does not exist in Kotlin. The only thing, so to speak, you can do in Kotlin is to iterate any objects that provide an iterator in Kotlin. So this might be, for instance, a range, and a range can be very easily created using this syntax with the 2 dots. So this here is the integer range from 1 to 10. Similarly, you could also, for instance, iterate over a string. So for C in Kotlin, you could print out the character C. So this will now go through the string character by character and print out each of those. So you can see we have KOTLIN, which in other words means that the string provides an iterator which allows you to go through the string character by character. Now another prime example is when we use some kind of collection. So let's say we have languages, which is a list of Kotlin, Java, and Swift. Then you can go ahead and say for lang in languages, and let's say print line lang is great. And this way you will iterate through all the items in the list, and it's going to print out Kotlin is great, Java is great, and
Надо
Swift is
пробел
great.
после grade поставить, конечно.
And apparently in the Kotlin REPL it doesn't actually print a new line when you use print line, so it's just going to still print out everything in just this one line. Now one more thing I want to mention here is that you can also use another function that's not directly related to the for loop, but you might use this in a for loop most of the time, which is the down to function you can use as an infix. So you could say for I in 10 down to 1, and this is just an infix function, so it's the same as calling a function down to on the two parameters 10 and 1, but it's more readable to put this in between, so you can say for I in 10 down to 1 print I, and I think I forgot to actually make this an uppercase T. Let's try to do it this way, and now you can see we have all the numbers from 10 down.
Блин, нихера, вот тут прикольно. For I in 10 down to 1 print $I.
In other languages, just remember that you don't have this syntax where you have actually three different parts inside the header for the for loop. Instead, you basically use a for in loop, which is not really less expressive. So if you want to do steps by 2, for instance, you can also use for I in 1 down to. You can also use for I in 10 down to 1 step 2, and that's gonna do exactly what you think. So it's gonna go down in steps of 2.
Вот
You
это,
could of
конечно,
course
нормальная
also do
тема.
this for the example where you go up from 1 to 10. So all those things
Блин,
you
как
can do
удобно.
with for loops in Java, you can
Намного
also do
удобнее,
with
чем
for loops
Java.
in Kotlin. It's just a bit of a different syntax. And with this you already have most you're gonna have to learn about loops when migrating from Java to Kotlin, because next when we're gonna take a look at while loops, they're not gonna be very different from Java. So let's move on now to the next lecture to look at the while and the do while loop.
Нихуёво. Так-то реально нихуёвая штука. Так, сейчас я отойду на минутку.